The first C-130, Hercules, rolled off the Lockheed assembly line in 1956. 70 years later, brand new C-130J Super Hercules aircraft are still rolling off the production line at the same company in Marietta, Georgia. No other military aircraft in history has stayed in continuous production for this long. Over 2,700 of these transport aircraft have been built. 70 nations operate them. More than 70 different variants exist, and the aircraft delivered today will likely still be flying military missions into the 2070s. The question is, how one airframe design has stayed relevant across 7 decades of warfare. If you subscribe to this channel, every video delivers a breakdown on the machines that keep militaries moving. That way you get the full story behind the equipment that rarely makes headlines. The answer starts with the cargo hold. When the Air Force wrote the original specifications in 1951, they wanted an aircraft that could carry troops, stretchers, cargo pallets, and vehicles, all from the same airframe. Lockheed designed a massive unobstructed cargo bay with a flat floor that sits at truck bed height. The rear of the aircraft opens into a full-width loading ramp that drops to the ground. Vehicles can drive straight in. Pallets roll on rails from the back to the front. Paratroopers can jump from the open ramp in flight. That single design choice, the wide-open cargo hold, is the reason the C-130 can do so many different jobs. A standard C-130 cargo bay measures about 40 feet long, 10 feet wide, and 9 feet tall. That is enough space to carry 64 paratroopers or 74 stretcher patients with medical attendants, or 45,000 pounds of cargo on pallets. The aircraft can be reconfigured between these roles in hours. One day it flies ammunition and fuel to a forward military base. The next day it evacuates wounded soldiers from a battlefield airstrip. The day after that, it drops humanitarian supplies from the air over a flooded region. This flexibility is built into the bones of the aircraft. There are no permanent fixtures in the cargo hold that lock it into a single mission. The airframe itself was built to survive rough treatment that would ground other transport aircraft. The C-130 was designed from day one to operate from UN-paved runways in combat zones. Dirt strips carved out of jungle, gravel fields next to forward operating bases, even frozen lakes in the Arctic where ski-equipped variants land on solid ice. The landing gear uses a high sink rate design reinforced for hard landings on unimproved surfaces that would collapse the gear on a civilian cargo plane. The high-mounted wing keeps all 4 engines and their propellers well above the ground, reducing the risk of debris damage during takeoff and landing on rough terrain. Dust, gravel, and loose soil get kicked up on every unpaved landing roll. The elevated engine position keeps those particles below the intake line. That rugged construction means the C-130 can reach places that larger transport aircraft, like the C-17 Globemaster, simply cannot operate from. Forward bases in Afghanistan with 3,000-foot dirt runways. Remote airstrips in Central Africa with no paved surface at all. Ice runways in Antarctica where temperatures drop below -40. The Hercules lands at these locations routinely, while other aircraft would risk structural failure on the first touchdown. Lockheed kept the aircraft relevant through continuous upgrades across its production life. The original C-130A used 4 Allison T-56 turboprop engines, producing 3,750 horsepower each. The latest C-130J Super Hercules uses 4 Rolls-Royce AE 2100 D3 engines, paired with 6-bladed composite scimitar propellers. These new engines and propellers give the C-130J 40% greater range than the older C-130H variant. Maximum speed increased by 21%. Takeoff distance dropped by 41%. The cockpit went from analog instruments to a fully digital glass cockpit with head-up displays for both pilots. The crew requirement dropped from 5 to 3. Every major system was upgraded while the fundamental airframe shape stayed the same. That is the genius of the original design. It was built with enough margin to accept better engines, better avionics, and better materials without redesigning the aircraft from scratch. The C-130 also spawned variants that no one imagined in 1956. The AC-130 gunship mounts a 105mm howitzer, a 40mm cannon, and precision-guided munitions on the aircraft for close air support missions. The MC-130 serves special operations forces with terrain-following radar and aerial refueling capability. The C-130 carries electronic warfare equipment for battlefield communications jamming. The C-130 uses retractable skis to land on snow and ice for polar resupply missions. Each of these variants starts with the same basic Hercules airframe and adapts it to a completely different role. That adaptability is only possible because the original cargo hold and airframe were designed with open space and structural reserves that later engineers could build upon. The global footprint of the C-130 creates its own momentum. With 70 nations flying the aircraft, there is a worldwide network of spare parts, trained mechanics, and accumulated operational knowledge built up over decades. A country that buys a new C-130J today can draw on 7 decades of maintenance data, repair manuals, and a supply chain that spans every continent on the planet. Training programs for pilots and aircraft mechanics already exist at military bases around the world. A pilot who flies the C-130H in one Air Force can transition to the C-130J variant with relatively short retraining. Mechanics who learned the airframe in one country can service the same aircraft in another. That global ecosystem makes the C-130 significantly cheaper to own and operate over a 30-year service life than almost any alternative transport aircraft on the market. Building a replacement from scratch would mean starting that entire support network over from zero, and no military wants to do that when the Hercules still delivers. The C-130 Hercules has flown for 70 years because Lockheed built an aircraft that could grow with the times. The wide cargo hold accepts any mission a military commander can imagine. The rugged airframe survives any runway surface on the planet. The modular engine and avionics systems accept generation after generation of upgrades without requiring a new airframe design. And the global supply network means no operator ever fights alone for parts, training, or technical expertise. Other military transport aircraft have come and gone during those 7 decades. The C-130 outlasted all of them. That combination of flexibility, durability, and worldwide support has never been matched by any other aircraft in the history of military aviation. If this video helped you see why the C-130 endures, subscribe to Steel Doctrine. Your subscription supports every breakdown we build, and we will keep delivering the engineering stories that matter.